Hello, welcome to another decidedly retro video. My name's Steve, and in this episode we'll be looking at building a Lazarustorm. This is a card which fits into the side of an Amiga A500 and allows you to put a Pistorm on the outside without actually changing anything really in the A500. You don't need to take the CPU out at all. There's only one thing you need to do, which is to link a jumper JP6 to allow the CPU clock to come to the expansion port. I've no idea why Commodore didn't do that by default, but anyway, that's the way it is. The card itself will only need a few components on there. You've got a decoupling capacitor, another bulk capacitor here, a resistor and some jumpers and the sockets. So anyway, let's get on and do it now. So these are the components I'm going to be using today. Although the board itself is for SMD, for, capacitors and other components, I haven't actually got those, but it doesn't really matter. For the bulk, there's a C2, which is a bulk capacitor. I'm just going to use this through hole, cut the bend the pins, cut them down, and solder them onto the board like that. I can make this 1K resistor easily into a one that will fit onto the board here, just by bending the legs. I have the pretty blue socket, which I got from Retro Renewals, just online on eBay actually. Pretty cheap and excellent for this job, and it's pretty blue as well. And of course got the SMD small capacitor here, which is for the decoupling cap C1. Now that will be the first thing to fit, because you can't easily do it once the socket is installed, and it gets it out of the way. And the second thing to do will be to fit this capacitor, the link, which will be used, I'll use part of the clipped off legs of the capacitor just to bridge those two here, there, and the resistor will go in the place of R2. And yeah, then finally fit the socket before putting solder onto all of these, bending the pins of the socket so that they will meet the board. That could be fun because these are relatively strong, but it shouldn't be too difficult. And by putting solder, pre-soldering all of these, it makes it easier, makes this thicker, makes it easier to put this on and solder the pins in place. Anyway, let's start with doing this capacitor. Wait for the iron to warm up. Right, a little bit of solder on there. Oh, I've forgotten in there to get the implement. Right, first things first, solder one of the pads. Now I can get the capacitor, tweezers, heat up the solder, bring that in, let go. That should be done. Now I can do the other side. Going to heat up the pad and the bit of the capacitor, and there we go. Just redo that. There we go. Now for this one here. This is going to be a bit more creative. So what I need to do, I know that this side over here is actually negative. I'll quickly clean that off. Make sure there's nothing on there from the manufacturer. Right. Again, I'm going to put some solder on these pads. Heat it up. Solder on. There we go. That'll make it easier when I want to fit this. Right, let's get the I'm going to bend these down, the legs down, and then straighten them out. So that they are, I'll attempt to make them into a position where there's no stress when they're laying flat and the capacitor's laying flat. That should do. Cut the ends. Move people down a little bit more, so that when the capacitor is laying flat, they are engaged. There we go. Now it's gone on the floor. I've got to go and search for it now. Right, I've retrieved it. Let's go onto the board. There we go. Just check no shorts. Okay. Right, now we have a piece of wire. I can make it into a link. Again, solder on the pad. Get the wire on there. Oops. Wire on there. Okay. Let's solder the other side. Now cut that away. Right, we need to bridge these two pads. There we go. I think that's a bit more. There we go. Now, 1K resistor. We need to have one side that's just look here. One side needs to be there, and the other one needs to come around the other side of the resistor. And join to the other pad. So let's cut this one off short so it doesn't interfere with anything. And that, well, the other one needs to cut about there. Fold that down. Again, let's just put a solder on pad here and this pad here. And now gently put that one into there, one into there. Right. Should have 2K, 1K between there and there, which we do. Now, we need to fit the socket. Notch on this side, notch to that side. And let's see if I haven't tried putting this socket, these sockets into here. These look to be spring loaded, which makes it a bit easier because they don't wander out and they go in the right place. So that looks good. So I can start with this soldering. Let's do one at each end to begin with. Is that straight? That is straight and true and fine. So let's do all the ones down this side. Pushing down onto the wire to make sure the wire is nice and hot. So the solder will go down. You don't get a dry joint, or a cold joint rather. Solder isn't flowing on these PCBs as nicely as I'd hoped. I usually buy my PCBs from PCBWay, but at the moment they can't take PayPal payments, which is a bit of a problem, and I don't want to use Payoneer. So this is my first purchase of PCBs from JCLPCB. Generally is good, but sometimes the solder I find doesn't flow quite as well as with the ones with from PCBWay. Anyway, those excuse me, those are the main components on. I now need to do the edge connector. So first of all, let's flow some solder onto these. I don't have to be too careful about what they look like at the moment. Just need to have a raised solder bed. I'll clean up a little bit later. I do want reasonably large amount of solder on there, ready for when the pin goes on. Right, now I can do the other side. As I say, I'll come back to the to clean up the other ones afterwards. Quite relaxing putting these things on. A bit of solder on here. You don't have to be too careful. Don't want to cover the whole pad. Just sort of stroke soldering iron. So this. Just even these up, stroking up the direction. Making sure it all flows. The solder melt in front of the soldering iron. So not going too quickly. Okay, let's do the other side. Even these up again. There we go. So you can see we've got plenty of solder on each of those. So now all I've got to do is bend these pins in. See if I can do it all in one go. Nope. So I'm going to first of all just bend these in using the pliers. As I've started to bend, maybe they'll be a bit easier. That's that side, let's do the other side. Could do it more. Let's see if I can do it with the fingers. It doesn't have to be perfect. Right, how's that? I think that's good enough. So what I'm going to do to keep it located, because it wants to slide off the solder pads. In the right position there. Get some blue tack. And I'll just solder one pin. Plenty of solder. Make sure of heating the pin itself. That's it. Right. Is that straight? Yep. So I can solder the other side. Remembering to heat the pin first, so the solder will flow underneath and onto the pad. That's reasonably good. So you might be able to just about see. Right. Now I can do the rest of the pins. Being careful not to bridge. But first of all, making sure I heat the actual pin itself. First. Sometimes it's hard to see which pins you've done and which one you haven't because it's so shiny. But this is why having the solder on the pad to begin with helps, because you then are easily able to bridge any gaps. That's that side done. Okay. That's okay. Right. Now the most important part. Do we have contacts and do we have bridges? Right, let's turn that to beep mode. That's right, because those are joined. Okay, that one's not connected. What means that? This is why testing the continuity is important. So it's hard to spot. It's so shiny. Another one. It looks fine. But, these again. Okay, those will check out. Let's give it a little bit of a clean. That's the build done. So volt capacitance, link, 1K resistor, and the sockets. So I need to clean up this bench, but it's not as nice with it. It's just sitting on the machine just like that. So I've designed a case for it. Let's clean it up a bit more, dry it out a bit. So this just sits in here. These go into these locations there, and that goes into there to hold the board securely. Then more IPA coming out. Then I just need some 8mm M2, sorry, wrong one, 8mm M2 screws, self tappers. Into the holes, screw up. One, two, three, four. There we go. That's nicely in there. And we're ready to put things together after you've cleaned up. You always clear up before you do the next stage. Right, now we have Pistorm and Raspberry Pi 3B. I've got an SD card in there. This is known working with a Pistorm. So notch is at this end, notch at this end. I'll first actually put some contact cleaner into the socket, makes it easier to move in, because of course this isn't a normal chip, so the pins will be rather wider. So make sure we line up the pins correctly and push down if it goes in. Go on. It's a very tight socket. It's not going. Right. There we go. It's starting to go. Very tight socket. Let's get that out again. I don't like the way it's going there. Let's try it without the case first. Got to be very careful not to bend the pins on these. Because they break. And then it's extremely difficult to get them out without damaging the PCB. Okay. Right. Again, pin one, into there, to there. There we go. This one doesn't want to go into this socket. There we go. Once it's been in once, it should have loosened up a bit. That's a very tight socket. Yes. Gently even up that end. Even up at this end. It's time to come. Come on. Okay. Whew, that was quite a lot of force for that. Don't like that, but it's very difficult to get dual wipe sockets that have that's the right size for a 68,000. Right, let's put it back into the case and see. It will fit. Let's just do 2 of the screws this time. This end. Right. Pin 1. Make sure it's in the right place. Push into the socket. It looks as though it's down this time. So all it needs now is the Pistorm to be slotted in place. And you can get ready to test. So we have the Amiga all ready to go. I'll switch it on. This is in stock condition, so it should just come up with, there we are, Workbench 1.3. Of course, no mouse at the moment because it hasn't booted. But let's just get the test kit. There we go. All as usual. So just eject that. Switch off. Now plug in the expansion. It's the first time into the thing, so it'll be a bit stiff. There we go. Right, let's switch on. What do we do? What do we get? Anything? Let's do a reset. What do we have? Oh, there we go. We have life. And there we go. Right, we've got 1 mega chip because I've fitted the extra extra RAM chips in on the motherboard and changed the jumpers. So we've got 1 mega chip and 860 megabytes of fast RAM. Right. Let's reboot. And let's sysinfo, do a speed check. Yay! Only 48 times faster than A4040. Not very fast, really. Anyway, it works. And well, gotta play a game, haven't you? So let's see. This is sort of a 16-bit dance party. There we go. There we go. I think that's a success, don't you? Well, there we go. A successful Raspberry Pi in a Lazarustorm. And I'll be putting a link to the case STL files, so you can build your own if you like. Anyway, that's about it. And if you'd like to like, subscribe, and all the other ding the bell and all that sort of thing, that will probably help other people find this video. Anyway, until the next time, goodbye.